All set.
All right, so now Jason's going to talk about hard drive IOPS and what the industry's doing to solve some of those problems.
All right. Thanks, Michael. All right, so hard drive performance, not a very interesting topic sometimes. People say, why don't you move to flash? Fair question. Now, for decades though, really the holy grail is how do you utilize rotational media? Whether your platters were several feet wide or 2.5-inch hard drives, it's going to be the most cost-effective way to store and recover data. So we want to talk about how do you do that effectively. So the first part is how do you define performance? Are you looking at throughput? Are you looking at IOPS? Are you looking at latency? The answer is really a combination of all of these above. Let's find out what we actually should be looking at and what you should be measuring in your fleet. So if we want to see a scaled out system or even a small integrated system, you want to look at your throughput at a target latency. If you want to game the numbers, there are ways to do it. But if you actually want to provide a service that people can use, whether that's in the public cloud, private cloud, you actually want to look at the latency targets because that's what you're actually going to perceive with your system. So what if your IOP target was, I want to get in the 99th percentile, I want my data back within 50 milliseconds. You may choose low queue depth, and you can do that. If you then change that and you wanted more throughput and you can tolerate, let's say, 100 milliseconds at P99, you can increase that queue depth and you can actually get a lot more performance from it. But will your user perceive that performance difference? Yes. Will your user perceive the latency difference? It depends. If you're in the tens or hundreds of milliseconds, maybe not. When you start seeing P99s out in the seconds, if you can count that fast, you probably should think about that. All right, and if you want marketing slides, this is always the good one. You can make that queue depth 128, and you're going to get a lot of IOPS, but you're not going to have very consistent performance. Your latency distribution is going to be really wide, and you're not really going to have the solution you want. So if you want a high-performance system, you want to manage your latency, and you want to ensure that it's low enough that your customers are happy, high enough that you actually get good throughput from the drives. But as I mentioned, this isn't a new problem. I'm just taking a snapshot in the last maybe decade right here. So we've had 3.5-inch drives that were spinning at 15K, power hungry, very fast. We had 10K drives in the 3.5 form factor. We then went to 2.5-inch drives so you can actually reduce the latency. I mean, many of us probably remember all these drives. There are no new drives in any of these categories because SSDs, dollar per terabyte, have taken over this entire system. Now the key is how do we leverage today's high-capacity drives effectively? So you have to choose capacity or performance, or is there some other way you can consider it? You can look at blending your workloads. If you have hot workloads and cool workloads, put them together and you lower your average latency, and maybe you have very long latency targets for some of those cool workloads and tighter latency targets for the hot workloads. You can also look at your data size and your data set over time. Some data sets cool naturally over time, so maybe the higher capacity drives come out and you can actually keep your same latency targets. You can also deploy read caches. That's only effective in some cases. If you have a pseudo-random workload, read caches work very well up to a point. If you have a truly random workload, read caches are not very effective. Or, as someone mentioned earlier today, you can short stroke the drives. But whoever's paying the check for short stroking the drives is probably not going to be happy. That was the whole point of these 10K, 15K, and 2.5-inch drives. So where does that leave us? I gave an example here looking at some of those 15K, 10K drives, and then the capacity single actuator drives that we have today. And I threw up 3 different bands. And everyone's workload will have different bands here. But I think these are a pretty decent representation. If you're in the thousands of IOPS per terabyte, probably aren't using spinning media anymore. That's moved to SSD. That's what's shown in the red. If you're in that yellow, that is the nearline capacity point. You can look at the performance, and you can see that if you happen to be in that 20-ish down to 8 IOPS per terabyte, you can probably find a good way to use nearline capacity drives. And if you're using archival storage applications, you can probably handle a lot lower IOPS per terabyte. And we have historically had archive drives in that. Now, if your workloads fall above or below these lines, you have to think to yourself, what do we do? Do we continue to go to the largest capacity? So here, in this example, maybe if your bottom line between that warm and cool was 16 terabytes, You're okay. What happens when the 18s, the 20s come out? You're probably not going to be so happy. But you know what? We're always out of IOPS. But you know what? We always find a way to deal with this. People said that 10 terabytes, we can't go bigger than 10 terabytes. Very few companies are stuck at 10 terabyte now. They found other ways, whether that's read-write caches, moving workloads off. We found a way to do that. But then we start having heat-assisted recording. Now we're starting to see bigger drives coming out. How are we going to do that? People thought in the past, even as recent as a few years ago, do you bring back 10K RPM? Honestly, that doesn't really solve your latency problem all that much. So that's why those really haven't taken off. Some ask for firmware optimizations to deal with some of these different queues that are sitting on the drive to get those high priority commands back quicker. Again, there's diminishing rates of returns. And then caching. Caching's a big one. So if you had a pseudo-random workload, you can deal a lot with that. Especially on writes, you can coalesce writes, as we heard earlier today. So you can solve the write path, but that read path is really challenging. So we talked about all the software implications and what you can do and how you think about your workloads. But what if there's also hardware that's going to help us? So now we're looking at multi-actuator drives. So instead of increasing the RPM, which get very small improvements, now you actually split the drive into two separate LUNs, and you get roughly double the throughput and double the IOPS on a drive. Sounds great, right? Everyone would go there if the drives were free or if it was a zero-cost adder. But even at a zero-cost adder, does it actually make sense? You have to think about some of the implications here. They're higher power, they're higher cost, they're a little more complicated, as you can see in the diagram here, and I'll show you in a second. And the mechanical design, we've asked teams that are building these very complicated devices now to have two separate actuators. It's pretty challenging. So as I mentioned before, HAMR and MAMR, they're coming very soon. So we're going to see drives 20 terabytes plus. If 10 terabytes was a pain point a few years ago and we made it through, are we really going to get to 20s? Are we really going to feel comfortable with that performance? To be fair, you're not going to have SSDs come to the price targets that we need anytime soon. The world's data sits on hard drives for bulk data. So managing that effectively is what you need to do. So again, queuing optimizations, caching, and software, but we also have to look at some of these other technologies that may get us over the hump, at least for the short term. So let's revisit that same chart we talked about earlier. With multi-actuator drives, you essentially reset the curve. You're not solving the problem, you're simply shifting it out further in time. We should get another couple generations of drives at a certain IOPS per terabyte. That's very interesting, very exciting, but up until recently, we only had one vendor that publicly announced technology, and that was Seagate last year. That was some of the diagrams I showed, and that's the drive on the left that we have here. You can see it in the booth. Recently, Western Digital also committed to this technology, and they also have demonstration drives. So it's not here yet, but we will be getting there soon. So you should think about what that means. Now we have multiple sources for this technology. It's no longer a single source risk. Now you have multiple companies out that are helping us solve these problems. But again, it's a partial solution. It's not everything. So I talked about some of the other challenges about thermals. I talked about power. You have to make sure your systems are actually ready for this. We've gone from drives that are in the 8 to 9 watts. Now they're over double digits again, so 12, 13 watts per drive. You have to think what that means. You also have to think about your system architecture. You start throwing higher capacity drives, a lot higher throughput. Is the system designed correctly? Do you have the NIC bandwidth to support what you need? If it's small block random I/O, you're probably good. If you're looking at HPC type workloads, there's very high bandwidth, you might have to reevaluate how you've architected your systems. So at Microsoft, we're making sure that our Project Olympus J2010 JBOD, also seen as the DX88, we're going to make sure they support these higher power and higher capacity drives and the multi-actuator drives. So we planned ahead. We made sure that we can handle drives that are 13 plus watts. And we believe we've also got the capabilities to have very good performance for the RV-AV characteristics. But as we start seeing these drives in quantity, we will test and we will validate to make sure that our chassis are capable of it. So when we find the need to adopt it, we can adopt that fairly easily. So again, to recap, I want to make sure that we all remember this. Multi-actuators alone are not the solution. So we're at, let's say, 2 today. We get 20, 30, 40 terabyte drives. If your latency profiles aren't changing, we have to continue to work on the software design. So keep that in mind. As a community, we also want to talk about what else we can do. We've talked about deterministic latency, a few other talks, specifically tail latency. This alone doesn't necessarily help a lot on the tail. It'll help a little bit. We need to continue doing things like the fast fail read that we did at OCP. We need to continue having these discussions to find out, are there other optimizations that we can share as a community and actually trade best practices. So what's next? Specifically on multi-actuator, both vendors have products out here, but we actually need to make sure they look and feel the same from a black box. So the command spec, how we treat multiple LUNs. I think Seagate mentioned earlier this morning, there are some questions that are still out there. Join us, come to the OCP calls, let's find out a way to make sure that we're building one set of solutions, not multiple solutions that look fairly similar. So we can start a work group, we can continue on the mailing lists, but if you have questions, please get involved. Think about what this means to your fleet. If there are things that you need, whether the firmware features, if you can help work with the drive vendors to help them understand your workload profiles, that would be helpful. Thanks.
Okay. Any questions for Jason?
You mentioned a number of strategies for getting past IOPS per terabyte bottlenecks. One of the things you mentioned was I/O priority. Can you say anything more about how you can utilize that to sort of get through those bottlenecks?
So I'll repeat the question a little bit in case anyone didn't quite hear it. So lots of strategies, and how do we deal with I/O prioritization? Internally in a software stack, we will typically have various queues in high priority, low priority, and span the gamut. The problem is if you oversaturate the high priority and you start getting the drive to throw all the IOs there or even dribble them out small amounts at a time, you may not get that deterministic latency back that you actually want. So we can manage it to a point, but ideally we want to bring in those tail latencies a lot more. So we're trying many different things, whether it's caching or IO priority, but we still need a lot more. Not sure if that directly answered your question. Okay. We can talk a little more in depth offline. Any other questions?
Hi, Jason. Seagate coming out with the dual-actuator CMR versus WD on the SMR. How your system going to deal with both differences of the two companies?
So the question was if there's CMR and SMR. So when we think about drive technology, SMR is an enabler to get us to lower cost, but CMR is perfectly acceptable. Our solutions can take both. So we have CMR and SMR in our fleet today, and we hopefully will see more towards the SMR side. That should be more cost effective, but if someone has a CMR drive that has a better TCO, we'd obviously take that as well. So they're not mutually exclusive technologies.
So do you actually think there is an IOPS wall, or is it just going to keep moving?
The IOPS wall is always there. Every company has an IOPS wall, whether that's, let's say, 10, 100 IOPS per second. But that changes over time, right? Every company has that line, and then they find out when you hit that wall, well, maybe that wall is a little further off. So if you're at 100 IOPS per terabyte, maybe we can deal with 80, maybe we can deal with 60. You'll see a lot of things change over time. Or if you really hit a true wall, you start looking at alternative media, so SSDs. Much better deterministic latency on SSD. But you have to, if you're in a multi-exabyte workload, it's a lot of SSDs. It's pretty expensive. So you find other ways to mitigate that latency. So if you have different services in a shared infrastructure, maybe you can deprioritize some of those cooler workloads to keep the hot workloads a little hotter and keep your customers happy.
Okay. Any other questions? Okay, thank you, Jason.
Thanks, everyone.